Okay, so first of all, again, thanks to the sponsors and organizers for making this event happen. Like I said, happiness can't be bought, but kayaks can, and that's pretty close. This talk is about railways programming, and it's organized in 4 sections. First, I would like to know about you guys. That will give me very valuable information throughout the talk. Then I'll briefly talk about me, so you know where I come from, where I'm standing, more or less. Then we'll get into business with railways programming and some final remarks. It's not Q&A, it's something else. There's Q&A, but I didn't include it on the table of contents. So, well, thanks for choosing this topic. There's so many other interesting topics and workshops and everything. So, about you. How many of you attended yesterday's talk by Sergi and Javier? Cool. They mentioned a few things that I build on. I assume that you were not there, and it's not a prerequisite, but if you're completely new to functional programming, that will be helpful. And that's the other question. How many of you have been doing some functional programming of some kind? Cool. Okay, so about half the audience. How many of you are working on or usually work with a language that supports functions as a first-class citizen or higher-order functions? How many of you don't know what higher-order functions are? You do or you don't? Okay, so on top of it all, I have some trolls in the room. Okay, so one done. There's something I didn't mention earlier, which is that I like to talk about me. And there's a lot of stuff to talk about when talking about railways programming. And that's what's to be expected. I have over 70 slides to talk about me, then 15 slides to talk about railways programming. So it's going to be a long ride. I'll have to go through some of the content pretty fast. So again, this is me. That's Slovenia. I'm currently working mostly in Scala. I don't know why, but I started doing problems that are a perfect fit for that language. But I was not always like that. When I started, I used to be a happy coder. I always just went for the happy path and ship and go. And I would say I was a code junkie. And like all junkies, I felt like I had an addiction. And then I saw this tweet. When you drink alcohol, you're just borrowing happiness from tomorrow, right? So you just ship, happy path, that's cool. But then, my code looked like this. What's wrong with this code? Okay, you all may have seen a few bits and pieces. It's Java code. I assume everyone is a bit familiar with this. Okay, maybe not all the queries on the API. And then when I would write code like this, eventually, that would be me, 3 o'clock in the morning, fixing code, some pager duty event, some big crash, stuff like that, right? Who has been this guy? I have. I'm sorry for it. The others, I admire you. You're my heroes. So back to the code. What's wrong? Now, please, give me some answers. Where could this go wrong? Any ideas? Divide by 0, right? What else?
Not a number.
Not a number. So, okay. Who had 2? I had this in production. Yay me. And then I said, okay, I have to deal with these errors, right? That won't crash, but what should I do? when I have the arithmetic exception on the divide by 0, or the number format exception when I'm trying to parse not a number. What should I do? But it gets worse, because I'm running through a list of strings. What should I do if there's an error? Should I stop running through this list? Should I ignore that error? So, should the code be this? Or should the for loop be inside the try-catch clauses? Right? Or should it be in the middle? There are several options. Maybe some errors I can deal with, maybe the others I cannot. And all these questions keep adding up. Moving on. Turns out there's a report on what Java developers do in this kind of situation. What should I do on my catch clause? Okay, this many log statement, this many just do a print stack trace, this many just catch and forget with an empty clause. Right? That's pretty scary. Meaning, I have to use a try catch because a checked exception needs a try catch. But it gets worse. What about the unchecked exceptions? I might not even have a try catch. So not only I don't know what to do when something goes wrong, but sometimes I don't even protect from a major crash when something goes wrong. And so this other guy just replied, well, maybe sometimes developers don't know what to do when things go wrong, because they're still struggling to know and make it work when things go right. So back to our code. This happens to be on the Scala repo, but just forget about that. It's just a way to run some Java code. Okay. So integer.value of 23 is of course 23. It's already an integer. Value of max value is the max value. Proof of that, when the input is a string, same thing. But what will happen in an overflow? That's a valid integer in the world of math, right? It is. It's just not a valid integer in the world of Java integers. Well, it turns out it's a number format exception, right? And what happens if the input is not even digits? It's also a number format exception. Come on. So we had to catch clauses, one for arithmetic exception, the other for number format exception, but actually there's 3 possible sources of error. Right? We should be able to handle this. So maybe, oh, well, maybe not. Maybe we should tell the user that this number is too big. Maybe this is dealt on some other layer. But it's potential error. And so, 3 o'clock in the morning, trying to fix everything, I fall asleep on my keyboard. And this guy shows up. It's the devil himself. Ignasi, I see you're in pain. I know it's Saturday night, and you don't want to be here fixing this production error. And I have a solution for you. You can write code, it can be done, without having all try-catch clauses messing around your logic. The original logic was very simple. It was just one-liner. 50 divided integer value of blah, blah, blah. And then you ended up with a huge mess, try, catch, and for here or there. And it could look like that. Okay. If you have to do 3 things, your code should be as simple as these 3 things. Even though one may have an application error, the other may have application error or system error, and the last one may even have system error. Right. But all this error management should not be polluting your source code. And Devil said to me, give me your soul, and in return, I will give you all this knowledge. And at that point I said, I'm not sure, to signing such a deal. But now that I know that it's possible, I will try and find it out myself. And so I embarked on a journey of discovery. I hopped on the train of knowledge and went for the unknown. And so on the train I met this guy. Hey, how are you? Cool. Are you on an Excel spreadsheet, finance guy? And he said, I'm not. finance guy. I'm not an Excel spreadsheet. I'm a developer. Oh, really? Yes, I am a developer. You're having weird dreams in that. Yeah, no. I never thought developers would have suit and tie. Well, some of us do. And I said, look, I'm embarked on a journey to all this discovery and this and that. And he said, no worries. I may be able to help you. Have you heard about typing and strong typing? And he said, and I said, maybe, but go on. He said, okay, you usually write code like this. And I said, of course, I'm a happy coder. Yay, pass. Yeah, but this is stringly typed. This is not strongly typed, right? And you have a prime minister that knows a lot about strongly typing. He even stated that, you know, un plato es un plato, un vaso es un vaso. So please follow his lead. Don't use a string if it's a name. Don't use a string if it's a surname. Make it clear through your intent, through your method signatures, what is it that you're expecting, right? And I was, whoa, that's deep. Yeah, hello. But okay, we made it to Brussels on this imaginary train of your dream. So I have to hop on. Safe travels. Hey, cool, nice meeting you. And so this guy came in and he said, hey, let me guess, because it's my dream, you're a developer, right? And he said, yes, I'm a developer. But just not a regular developer. I'm a functional programmer. And I said, whoa, that's new to me. I'm discovering there's all many things that I didn't know that I didn't know. And I said, okay, can you tell me something about functional programming? Yeah, just scratch the surface. First thing you need to know, functional programming tries to just use pure functions. And a pure function is such that given the same input, will always return the same output. So there's no side effects. And on top of that, a pure function on your code is such that if it's not used, it can be completely removed because it's not mutating state, it's not doing anything. Okay? Oh, and also, we don't like exceptions. Okay, can you give me an example? Let's forget about the example. Let's get through some more ideas. Okay. Imagine you have an array of blue things, and you have a function that converts a blue thing into a red thing, like this. Right? You have a people, and this is integers representing name, right? So this function could be get age, or get name, sorry. So mapping will let you run through this array, and with the function that you just gave me, go from one to the other. Oh, okay. What else? Imagine that your input now, or your blue things are strings, and you want to tokenize each of the strings. That would be the output. Okay. Let me pause a second. Is anyone familiar? Does anyone know where the next slide will be? Come on. Sergi, please. No? You know. Okay. I want this output, not this output. So in this case, we don't use something called map. We'll use something called thank you. Interactive audience. Yes. So, of course, we use flat map, and I said, okay, but I just don't get it. You were just telling me something about functional programming, now you tell me something about map and flat map. Yeah, Ignasi, but he said, map and flat map are higher order functions. They are using a function as an argument, right? Okay. Just sleep on it. Oh, that's a bit Inception, a dream. Yeah, okay. Think about that. You have to also think about all this type stuff. And I said, cool. Is there anything else I should know about functional programming? And he said, yeah, there's this thing called the monoton. It's just a monoton, the category of the functors. So, no big deal. And I said, what? Oh, okay. Just forget it. It's not so important. So, yeah, safe travels. Keep going. Just keep adding some bits and pieces to your newly acquired knowledge, and maybe it all adds up. Cool. And so, I switched trains, and I met this monk. hey, may I join you? Sure. Let's share the car. And he said, oh, we're doing here and there. We started some chit-chatting. Well, what's that you're reading? And he said, I'm reading Trainspotting. Trainspotting is about Renton, who's a software developer. He's a code junkie, like I said. Well, I know the types. I know the types. We always end up like this. 3 o'clock in the morning on 3 in the morning on a Saturday evening. It's not nice. And he says, I know, I've read all the book. It's my third or fourth time. At some point the book says something about monads. Hey, stop there. I know monads. It's a monoid on the category of end of functors, right? And he said, oh, come on, shut up. You're just repeating some nonsense you don't know about. Exactly. And it won't help you. It won't take you anywhere. You may get more insight by practicing, by learning all of this. And I said, can you help me there? Yes. I hear, said the monk, that you are on a journey to improve. And I said, yeah, that's my intent. Okay. So first thing is you have to change your context. Go away from other happy programmers. Learn from non-happy programmers. Learn from other people. And through this learning, you will make it out of your pit of poop. And on top of that, if you also have someone who helps you, who keeps motivating you to improve, you will eventually make it an ascent into the sunlight and just not look at the shadows. Wow. So I have to think about types. I have to think about math and flat math. And now you come with all this philosophy thing. I think that's too much. No. Let's get into some details. Let's see some code. Imagine this interface. This is Java 8 code where, so okay, we have to hire other functions, right? And see how flatmath gets a function where the return type is also a try. Because, okay, we want all these to be unboxed, like we saw on the array of blue things, right? And then when this thing is put together, you may need to get the contained data. And you may need to ask, did something succeed or did it fail? Okay, I think I'm not sure where this is going, but I think I get it. Any questions here so far? No? Cool? Everyone? Sure. Awesome. And he said, implementing it is quite simple. Imagine you have a static method anywhere where you can provide this supply. Your supply is something in Java 8 where you have no arguments and you provide something of type T. This operation may succeed if there's an exception thrown. It would fail. But that's completely bound inside this piece of code. From the outside, there's no exception thrown. Only this escapes. And that would either be a success or a failure. There's no exception there anymore. And I said, okay, but how will that help me? That will take you to writing code like this. Okay, how would that work? You may not have all the bits and pieces yet, but you're getting there. And I said, well, that looks quite similar to what the devil said to me. Exactly, but you're still not there. Let's try and see how that could help on your example with the integers. Okay. We have a first function, which given a string, will try to give you an integer back. We call it toInt. We have another function, which is divide 50. Okay, naming could be improved, but bear with me. Which given an integer, will try to do this operation. And finally, we have a -1, which won't fail, except, okay, there's an error on this code, and it could fail with an underflow. But it's fine. Let's continue. But I still need to put all the pieces together. Yeah, but okay, we just made it to my station, so I need to leave it here. Just sleep on it. Come on, not again. Can't anyone give me all the pieces together? Yeah, not my thing today, sorry. So I made it into Tokyo, and I started visiting the city here and there, and on the train station I met this fine lady. Hey, what's that you're reading? Oh, it's a very interesting book. It's a book about promises. And I said, oh, is it a love story or something? And she said, no, it's about concurrency. And I'm like, what? Yeah. Actually, promises or futures, depending on the language you are, it's something quite similar to. That's right. Have you heard about that? Sure. I just met this monk who told me all about it. So I tried. It's an operation that would either succeed or fail. But the future is more or less the same, but it will eventually succeed or fail, right? Okay. So, can you tell me something more about that? Oh, I'm sorry. Our train just arrived. And so I hopped in, and David Bowie was on the other side. I went, what the fuck? David Bowie, what are you doing? Oh, I like Tokyo, I like Japan, and I like this and that. Cool. What are you doing here? He said. I'm not so sure, but I'm trying to learn about railways programming. I said, really? I know a lot about railways programming. Oh, come on. Sure I do. Every time I'm touring, I have lots of time to spare on airports and everything, so I keep reading stuff, and I know a lot. Do you want me to teach you about railways programming? And I said, of course, David Bowie, I want to. Okay, Ignasi, now listen. Railways programming is a very simple concept. Imagine you're on a track, right? And you have your input. But your function may fail, or it may succeed. So far, so good. We're all familiar with that. But when you compose all these, you may fail, and then you go to another function, and it may fail, and then you go to another function, and it may fail, and eventually, you get the final response, right? Done. Easy peasy. Hey, and where did you learn all that? Okay, there's this guy, Scott Lushin, who has all blog posts and a talk and some slides. He explains extremely well. Okay, then why am I doing this talk? He said, I don't know, it was your choice. But maybe you can put some bits and pieces together for someone who never heard about that, who is not familiar with Scala language or some other functional programming. And I said, okay, the main idea about railways programming is that in your happy band, right, you keep on the green track, and if eventually something goes wrong, you're stuck on the red track, right? You just don't throw an exception and leave, right? So you have a validate function, or an update function, or a send function, which you can actually completely close. And as long as your inputs and outputs of your function are properly typed, and your types display the intent that something may succeed or fail, you will be able to compose all these functions very easily. Right? So railways programming is all about treating your failures, but most importantly, typing your failures. When things can go wrong in your system, you have to know in your domain what a number format exception means. So it has to be transformed into what your domain understands as a number format exception in a specific function. We've seen we can have two number format exceptions, and they could mean two completely different things. We have to have those typed, but we don't want this information polluting everything. We can just keep it on a very small context. Okay. Also, you have to start thinking of failures as something completely different from errors. Okay? Failures are those things where the runtime doesn't know what to do, but the programmer at development time does. So, if you're a good developer, you should take care of those failures. Errors, on the other hand, are situations where not even the developer knows what to do. Railways programming will help you to deal with failures, not errors. Errors have to be dealt with in a completely different fashion. You have to have some monitoring system, something out of band, something in a different process, no data center, not on the place where the error may happen. On top of that, rigorous programming is not something that you would use across nodes, even if it's dealing with failures. Okay. For instance, there's another pattern to deal with errors in distributed transactions, which is science, but that's topic for another story. Let's just focus on this specific kind of failures and dealing with those. Okay. Let's see some code. It's quite immediate to see what this does, right? Let's try and use something new called identity. Identity is something quite like promises and tries, but it never fails. It just succeeds. Okay. So the regular code and the code using tries is immediately telling me what's happening, what's the business logic, isn't it? Okay. So how can we rewrite this code or this code? Well, we've seen that we could rewrite the functions as a function that returns tries, right? We've seen this before. Maybe our logic is just as simple as this. And all the error management and all the typing of my errors, okay, I didn't do all the conversion of the potential errors into my domain in these functions. But if I did, it would be next to where the error happens, not somewhere else in the try-catch clause where someone is using my function, right? Is there a question? No? Cool. Should I keep going? Perfect. So it's pretty clear that I'm not polluting. I don't know what this is doing. I have to read too much to separate the bits and pieces. Well, this is immediately clear. And on top of that, once I build this, okay, not the best of the namings here, by, it's pretty clear that it will try to give me the result, right? And the most important thing, when we run it with these potential output inputs, what will the outputs be? Well, it's pretty simple, and it's all clear. And anyone who is using me will be able to, okay, if these were converted into my domain, decide what to do. Because I will be talking about my domain, we'll be talking about my business processes. It will be very easy to either display an error or just use some fallback, compensating operation, whatever. And because I will not be using non-performant exception anymore, I will be stating in the specific context what the input was and how that affected my business. It will be easy for the upper layers, for my clients to deal with that. Okay. So we're actually pretty close to this. Because this is Scala code and it's just syntactic sugar for, okay, let's go back. Sorry, this. Okay, see how this line is invoking toInt with this input. Then the output here is a try of integer. Over the try of integer, we flat map something. We could flat map another time. We could not, and flat map and blah blah blah. And this is a pattern that happens all the time. And it turns out that Scala and several other functional programming languages use so often that have it embedded on their syntax. This is syntactic sugar for toInt. This is actually the content of the try of int. Over that, I flat map with this function. Then over that, I flat map with that function. Over that, I map. So I get rid of the extra noise that, sorry, working with a database driver that only provides synchronous implementation, while this guy is working with some newer or more async-friendly database, and so I can do that, right? But it should not pollute my business logic. It should be all the source code is in the repo with the slides and everything. So yes, no more problem. Is that clear? At that point, David Bowie said. And I said, yeah, it's sinking in. I think I almost got it. Is there anything I need to know, David Bowie? Yeah, lots of stuff, but in particular about Rails programming, there's one last thing you need to know. And that's easy to remember. Don't be Javi. And I said, what? Who's Javi? You know, the inventor of HappyPath. And I said, what's HappyPath? It's like export HappyPath, unicorns, and rainbows. No. HappyPath is not testing your recovery. You recover. Recover is what you do over a try or a future when something goes wrong. Okay. So, because you are now dealing with errors and you are now familiar with all these domain situations where something's going to go wrong, you will also need to test them. Just don't be happy. Just don't stop after the first step. Keep going. Okay, cool. I'll do that. And with all this said, it's just the final moment for some final remarks. Like Renton, like he starts the movie, choose life, choose a job, choose a career and a family, choose a fucking big 4K monitor, choose SD, more RAM, and i7, choose solid, TDD, BDD, choose a continuous integration, continuous delivery, auto provision, self-getting, auto-scalable, choose dragging yourself around the city to attend a coding dojo, choose your colleagues, choose your laptop back and matching sneakers, choose a Star Wars t-shirt, choose your future, choose to manage your errors, choose life. Thank you. Questions? I have some go if you want, if there's something that maybe through live coding it's more clear. Any doubts? Not to brag, but I had the chance to use this in production. It's just a bliss. Your controllers is just this small. It's extremely clear what's going on, and you just include a filter in front of that can convert all the possible failure messages into, I don't know if it was an API, the proper 400 something, or if it's UI, then the proper view with yellow or red message and everything. It's a but remember to type anything that can go through your red track on the railways ID. No? That it? Cool. Thanks. Oh, there's slides and tweets. Thank you. Okay, so on top of it all, I have some trolls in the room. Okay, so one done. There's something I didn't mention earlier, which is that I like to talk about me. And there's a lot of stuff to talk about when talking about Rails programming, and that's what's to be expected. I have over 70 slides to talk about me, then 15 slides to talk about Rails programming. So it's going to be a long ride. I'll have to go through some of the content pretty fast. So again, this is me. That's Slovenia. I'm currently working mostly in Scala. I don't know why, but I started doing problems that are a perfect fit for that language. But I was not always like that. When I started, I used to be a happy coder. I always just went for the happy path and sheep and Go. And I would say I was a code junkie. And like all junkies, I felt like I had an addiction. And then I saw this tweet. When you drink alcohol, you're just borrowing happiness from tomorrow, right? So you just ship, happy path, that's cool. But then my code looked like this. Okay, so first of all, again, thanks to the sponsors and organizers for making this event happen. Like I said, happiness can be bought, but kayaks can, and that's pretty close. This talk is about railways programming, and it's organized in 4 sections. First, I would like to know about you guys. It will give me very valuable information throughout the talk. I assume that you were not there, and it's not a prerequisite, but if you're completely new to functional programming, that will be helpful. And that's the other question. How many of you have been doing some functional programming of some kind? Cool. Okay, so about half the audience. How many of you are working on or usually work with a language that supports functions as a first-class citizen or higher-order functions? How many of you don't know what higher-order functions are? Well, you do or you don't? Well, then I'll briefly talk about me, so you know where I come from, where I'm standing, more or less. Then we'll get into business with railways programming in. Some final remarks. It's not Q&A, it's something else. There's Q&A, but I didn't include it on the table of contents. So, well, thanks for choosing this topic. There's so many other interesting topics and workshops and everything. So, about you. How many of you attended yesterday's talk by Sergi and Javier? Cool. They mentioned a few things that I build on.